We're going to continue working with exponents today and learn a few more types of exponents and a few more different situations we're going to see while using the rules of exponents. Again, you need to take notes, so get that material now if you don't have it. I know in the last video we kind of went over all of this stuff, but here's a quick review: how to identify the base and the exponent. The base is the big one, the exponent's the little extra, and scroll down. We tried to evaluate by actually multiplying it, and then we talked about rewriting. That's just when you write 6 times 6, or you write the 2 6 times with a little dot in between. And that's another thing I don't know if I've mentioned, but I like to think of the exponent as the directions. Not only is it officially how many times you use it as a factor, but I kind of like to think about it as I write it down 3 times and multiply. So this tells me to write it 1, 2, 3 times, okay? Let's skip ahead. I think we talked about the product of powers property in the last time. Writing things out makes it real easy. We skipped ahead, figured out that all we have to do is count. Now, I'm not sure if we went through rewriting an exponential notation or not, but we can go over that again. That's always a good review. So let's take a look at these few examples here. Again, all you do is count them up. This is pretty easy. There's 1, 2, 3, 4, 5 of them, so this would be 2 to the 5th. 1, 2, 3 of these, so 2 to the 3rd, but then 3 to the 2nd. 8 squared times 7 cubed. That's 8 with an exponent of 2 and 7 with an exponent of 3. I'm going to get over to the board in a second. Well, you guys take a look at this one. There's a missing number, so what's our missing exponent? Well, if you know that 4 plus something needs to equal 8, it's obviously another 4, okay? I know we talked about having no exponent at all, but that's why I said if I look at this, this tells me to write it down 4 times, so it's always to the first because I've written it down at least once. If you see it, it's there, right? So let me scroll to a good place and go over to the board. This is where we're going to pick up our notes today. Again, if I ever go too fast, you always have the ability to pause. You can rewind and go over things. So if you don't see any exponent at all, it's always a 1. And that's pretty easy. So if you look at combining these terms using the product rule, a lot of people would say x to the 4th, but just throw that little bad boy in there. Again, if I wrote this out, I would have 4 of them, and then there's one more right here. So there you go. And that equals x to the 5th. But now we know this fantastic rule, so we have to do all this long stuff. It's kind of a good way to get yourself set up for watching what happens and how the patterns work. So let's take a look at some of the other situations you might see when working with the product rule. One thing we need to keep in mind, exponents only raise the number it's touching. And now it might not exactly be touching, but that's the term we're going to go with. Let me scroll this up a bit. Okay, so what I mean by that is when you look at something like this, you know that it's y to the 4th. That 4 only applies to this number. Now again, they're not physically touching, but the one it's right on top of. And this is x squared. That 2 only refers to the x. So when you look at something, let me give you some other examples here. I'm going to ignore that phone call. So if I had, it's not x to the 3rd, y to the 3rd. It's not xy to the 3rd either. If I wrote this out, I would have x and y to the 3rd. That 3 only refers to this guy right here, okay? That is a huge thing to keep in mind because we are going to see some things where there's double variables next to each other, and you have to know which one's which. And now remember, how many times did I write down the y? 3 times. It told me to write it down 3 times. How many did I write down the x? I wrote it down once. So what I tell students, so they don't really get confused if they ever have something that looks like this, where you have many variables in a row. Maybe you have m, n, cubed p to the fourth. Go ahead and give every single letter or variable in that list. Go ahead and put that one there to help you remember that it's not m to the third as well. Okay, it's kind of like a placeholder, I guess. You might have coefficients, and you need to remember what a coefficient is from our unit on equations. Okay, that is the number that's with, it's usually multiplying a variable. Okay, so don't forget what a coefficient is. So you see this? The coefficient is 3. What is your base? It's only x. Because that squared, that 2, is not touching the 3, and my exponent is obviously this little 2. So if I were to write this out the long way, it would be 3xx. This exponent has nothing to do with that number 3. So see how I just drew that arc there? If I have to draw over or connect over another number or a variable, it doesn't belong to that one. Okay? Let's talk about using the coefficients with a product rule. This is going to be pretty basic for us. We get to multiply what we can and use the product rule to combine any similar bases that have exponents. Okay, so let's take a look at that example. Again, if I'm going to write this out, that's 3x squared, and then times 3. Told me to write down 3 more of those. Now we're going to go back again to our equations unit. Remember some of those properties of multiplication? Remember the commutative property? Commute means to absolutely move around. So I can move these around. They don't have to stay in this order. So I could write 3 times 3 and then do all my x's. 2 from the first. And 3 from the second. So I know how to multiply 3 times 3. 3 times 3 is 9. Okay, and then how many x's did I write down? I have 1, 2, 3, 4, 5. 9x to the 5th. So if you don't want to write all that stuff out, you can do 3 times 3, and then you have 2 plus 3, x to the 5th. I do like to write it out longhand no matter what, just to kind of show you guys what's going on. It's good to kind of take that in and see what's actually happening here mathematically. So take a look at this one. Try doing this one yourself. I'm going to scroll up on this while you work on that for a sec. Some of you might already be done. If not, pause the video, finish working on it, and see what you get. I have 5 times 2 equals 10. There's 4 x's here and 3 here. And then there's only 1 y. The most common question I get here when there's 2 variables is which one goes first. And I say always write it in alphabetical order. I don't care if the y comes first in the problem, but x and then y. That'll also be helpful to get in those patterns because we're going to start graphing linear equations next. And in a ordered pair, x's always come first. So always do it in alphabetical order. Now, Math Excel won't count it wrong if you wrote 10 times y times x to the 7th. That's okay too. I just really don't like that. Try to do it in alphabetical order and just stick that way for now. There's one more here, one more challenge for you to work on and try to see what you can come up with there. Again, I'm going to let you work on it. Pause the video, see how you can do, and we'll go over the answer in a second. Sometimes I just like a clean board. It's very confusing when we get all those numbers up there. So I got 7 times 2. I got 3 x's and 3 more. And then I got 6y's and 2 more. Okay, 14y to the 8th. Let's talk about special exponents. 0. I know we talked about it yesterday up on the board, but I want to go over it again here because this is a concept that we need to really kind of grasp and know what we're doing. It's easy to slip up with this one. Well, remember how I said the exponent tells you how many times to write something down? If I have x to the 0, how many times am I going to write that down? None. I do not put a 0. It doesn't equal 0. Let's think about why that's so important to know. If I have a problem like x to the 0 times 5 squared, and I think that x to the 0 is 0, what you're telling me is now I have 0 times, well, this would be 25. 0 times anything takes it out. It makes everything 0. It kind of just wipes everything out, and that's not what I want to do here. It's telling me not to write it at all. But there is something there, so I don't want to just leave it with nothing. And a lot of us know mathematically nothing is 0, but that's not really what's going on here. So let's take a look. What can I put in its place that's not going to change my answer? I still have x to the 0 times 5 squared. What's going to replace this that holds my answer for me? When we add and subtract, we use a 0 placeholder, and that's another property of addition and identity. The only one that's really going to kind of make sure we know that is a 1. Okay, and so we're going to talk about why that is so. And maybe that was a confusing way for me to introduce it, but let's talk about this in more detail. Any non-zero number to the 0 power equals 1. Any one. Okay, so we're talking about 2 to the 0. I'm talking about 3 to the 0. I'm talking about 3,467,532 to the 0 is also 1. And I'm going to show you why. Okay, so here I have a list of multipliers. So this is 2 times 2 times 2 times 2. That's 4 of them. Okay, so when I drop down to 2 to the 3rd, how do I go from 16 to 8? I kind of divide by 2. Sorry, my pen is off now. Okay, so 16 divided by 2 is going to give me, oops. 16 divided by 2 is what's going to give me 8. And that's just like not multiplying by another 2. On our way up with exponents, we absolutely add another 2 and multiply. So on our way down, we take a 2 off because we're dividing. Now let's see. If I go down one more, again, here I divided by 2. I divided by 2. And then what's 2 divided by 2? 1. And so I have 4, 3, 2, 1. Next exponent, logically, is 0. I'm taking the 2's away. It's a lot to conceive of. So let's look at our 7's. I want to show you how it does it with 7's as well. If I take 7 times 7 times 7, I'm going to get 343. If I divide by 7, I get 49. Divide by 7, I get 7. And I divide 7 by 7, it's 1. Okay? For some of our purposes, I like to think of that as I don't write it down at all. That works with multiplication. Okay, so for now we're going to look at that. Let's take a look at this practice that I have here. I have a little page for us to work on. some more examples that'll help really kind of bring this idea home. This opened on my other screen. I have all of these examples up here. If you'd like to pause the video now and go through them all and then see how you do, that's fine. Go ahead and do that. If not, at any time I'm going through, I want you to pause and work ahead as soon as you feel comfortable. Now, it's okay if you get them right. I'm sorry, it's okay if you get them wrong. One thing I want to point out to you, though, is this little guy right here. Look at the M and N. M and N. This 3, this cubed, doesn't apply to the M, just the N. Remember, this is M to the first, okay? That's the only heads up I want to give you. I see some 0 exponents in there, so be wise and remember what we did. If you forget, just rewind the video a little bit, okay? So on this one, if I write it out, I have 2 times 6, and then this is x to the 0, which I know is 1, or you can make that choice right now just not to write it. Don't write it at all. So I know 2 times 6 is 12. I only have 3 x's. 12x to the 3rd. Okay. Let's look at this one. I'm not going to write everything out, but I'm going to go 2 times 6 times 2 is 24. And then I have 3, 4, 5 of these. Other than some basic multiplication, this homework is essentially adding. And that's not too hard. I'm going to calibrate my screen, so hang on 1 second. I'm going to pause the video so you don't have to watch that. But if you would like to pause the video yourself right now and work ahead, again, please do so. Okay, so let's move on to number 3. Again, I'm not going to really write all this stuff out the long way, and I'm just going to kind of show you how I keep track of what I'm doing. Let me get that information out of my way. So remember, order doesn't matter. So for me, 4 times 5 is 20. 4 times 4 is 80. I could also do 4 times 4 is 16. 16 times 5 is 80. Doesn't matter. And then I have 2, 3, 4, 5 B's. That's not so bad. And then there's 2 of them here and 2 of them here. 15x to the 4th, okay? And I'm going real quick, so again, at any time, just pause that video and do them yourself. In fact, right now is a good time if you haven't been already. These are like the easy, the good, the bad, and a little ugly, but you're going to find that these are really easy to do, okay? So go ahead and work through those. Hopefully you've already worked through them and paused the video like I suggested. So here is 10, and now I have 2 m's here, 1 there, 3 and 3. I have 8, 3 m's, none anywhere else. 3 plus 2 is 5. Okay, now there's some good stuff here. I have x's, I have an x, no x's, and 2 x's. So I have, this is a 1. 1, nothing, plus 2. I have 3 y's here, 1 here, and 3 here. So I have 3, 4, 7. Then I also have 5 times 5. Oh, yeah, if you want to know about order, numbers come first, then exponents. But again, x cubed y to the 7th times 25 is essentially the same answer, okay? 6 times 4 times 6. Okay, check that. If you want, I have 3 x's, 3 more, 3 more. 3 plus 3 plus 3. And then I have 2 y's plus 1 plus 2 y to the 5th. It's really not that hard to keep track of these. Okay, so that's just some basic stuff to do with the product rule. Let's take a look about some other special situations you might see. Parentheses. Parentheses are a game changer when it comes to exponents. When you have parentheses around a group of numbers, everything inside is the base. Because the exponent touches the parenthesis, so it raises that. It raises everything inside. And so remember when we had 3x squared? And I said that's just 3 because this is the only one it was kind of touching. Well, now if you look, my exponent touches this, and this is around everything. So you kind of distribute the exponent kind of like it's 3 squared and then x squared. That's kind of how that works. So to simplify this, obviously you can do 3 times 3. And that would be the answer. I've noticed on Math Excel, the program that we use, if it's something simple like squared or cubed, it wants you to do it. But if you end up with something like 3 to the 17th, it does not want you to multiply that all out. And it will tell you to rewrite it with an exponent, okay? Let's look at something else. Fractions. Now, my parentheses didn't print very big, but as you can see, I want to cube 1/2. So that's what this looks like. Remember when we multiplied fractions, we multiply straight across the top. So 1 times 1 times 1 equals 1. 2 times 2 times 2 is, well, you can write it with an exponent, or since that's doable, you would get 2 times 2 is 4 times 2 is 8. Okay? That's how it works with fractions. There's another kind of example you're going to see, and it's something crazy like this. And I say crazy because we're just using this for a base. We're not actually going to try to calculate this. This is only 7th grade. We don't need to worry about how these play out. But you have to know that the base is everything inside the parentheses. So identify your base first. And I can clearly see what's inside the parentheses. My base is x plus 5. I'm not going to lose those parentheses. I want to keep that there. And then the same rule applies for product. It's 2 plus 4. And that is how you combine a problem like that. You will see a couple of those coming up. And I'm not asking you to actually multiply that out. Binomial expansion is not something we do in the 7th grade. Okay? Hopefully that's all the information we need for now. And we'll add some more rules tomorrow.